The question is asking us to calculate the enthalpy change for the formation of ethanol. And in order to do so, we have given the enthalpy of combustion for carbon, enthalpy of combustion data for hydrogen, and enthalpy of combustion data for ethanol. These are the data. And the question is also specifying us to do the calculation using all the three methods. When I'm saying all the three methods, it involves the energy level diagram, energy level diagram, energy level diagram. It involves the formula method. Formula means enthalpy of reaction is equal to enthalpy of products minus reactants using that particular formula. And the third method is using bond enthalpy. So all the three methods, we have to, using all these three methods, we have to solve this question. For the time being, let's focus on energy level diagram method. So now our focus is on energy level diagram method. So in order to proceed with this particular question, first let's find out, let's convert all the data into equation format. So standard enthalpy of formation of ethanol. So in order to get the standard enthalpy of formation of ethanol, we have to get the relevant equation. So formation of ethanol. Ethanol has to be formed. And for enthalpy of formation, we need 1 mole of ethanol from its respective elements. So carbon, hydrogen, H2, and oxygen. These are the elements in their standard states from which ethanol can be formed. So C2H5OH. Now in this, there is 2 carbon. So when I'm balancing it, I'll be getting 2 here. Hydrogen, there is 5 plus 1, which is 6. So I need to have 3 H2. And there is only 1 oxygen here. So I'll be having it as half here. I have to maintain this as half only. I cannot multiply it throughout by 2 and make it a complete equation, because enthalpy of formation means it's for 1 mole of the substance being formed. So let me take this as X, something what I'm asked to find out. Then I'm given enthalpy of combustion for carbon. Enthalpy of combustion means I will be burning 1 mole of the substance in oxygen. Combustion means burning in oxygen to give me the product. It's 1 mole of substance. So here the equation is in itself balanced. I need not have to balance it out again. For this, the energy is provided to be minus 393 kilojoules per mole. Third one, the next one actually, it is given to be combustion for hydrogen. Hydrogen, when I'm burning, when I'm igniting hydrogen, I'll be getting hydrogen plus O2, giving me water. For this, it is enthalpy of combustion, but enthalpy of combustion is for only 1 mole of the fuel being burnt or hydrogen being burnt. When I'm balancing it out, I have to have a half here because I want 1 H2 here, just like I was having 1 carbon. So for this, the data is given to be minus 286 kilojoules per mole. Next, methanol is subjected to combustion. So I'll be getting C2H5OH. When subjected to combustion, it would be burning in air, burning in oxygen to give me carbon dioxide and water vapor. So when I'm balancing it out, I'll be getting 2 carbon dioxide, 3 water molecules. So in total, 2 2s are 4 plus 3 7. So this will be, here there are 7 oxygen atoms. Here it is 1 and 2. So this will be 3 O2. 3 O2 means it will be giving 6 plus 1 is 7. So both the sides are balanced. For this, it will be minus 1368 kilojoules per mole. So from the given data, I have formulated the equations. Now I'll be using these equations to generate my diagram, my energy level diagram. So here I'm having my equations what I had made. Now I'll use this to formulate the energy level diagram. And for generating the energy level diagram, I'll choose the equation which is having maximum number of compounds to be at the top. So when I'm analyzing this, I'm having C2H5OH plus 3O2 plus 2 carbon dioxide plus 3 water molecules. This equation has maximum number of species in it. 1, 2, 3. 3 compounds are there in it. None other equation is having so many compounds. This one is having elements. A lot of elements are there, but there are no compounds other than the last equation. So the last equation, I'll be putting it at the top. So C2H5OH, this has to come at the top, plus 3O2 gives 2 carbon dioxide plus 3 H2O. And for this, the energy is minus 1368. Now, here there is only one species, but here there are 2 species. Just because here there's only one species and here there are 2 species, in order to avoid confusion at a later point of time, I'll start off with the side which is having more number of species in the form of compound. When I'm saying species, I refer to compounds. On my left hand side, I'm having only one compound, but on my right hand side, I'm having carbon dioxide as well as water molecule. So because my right hand side or the product side is having more compounds in it, I'll first keep my focus on that side which is having more compounds. So first species out there is carbon dioxide. In order to get carbon dioxide, I have to depend on carbon plus O2 giving me carbon dioxide. So carbon dioxide, I can replace it as C plus O2, but I need 2 carbon dioxide, meaning I have to multiply this by 2. So what will I get? 2C plus 2O2 gives me 2CO2. So it would be 2 times the data given to me. 2 times the data given to me, which is minus 393. Now, whatever I have not used, 3 water molecule, I'll be simply copying it like that itself. Now, I'm done with carbon dioxide portion. Now I have to keep my focus on water molecule. So when I'm focusing on water molecule, I'll be having H2 plus half O2 giving me water molecule associated with minus 286 kilojoules per mole. But I'm not dealing with one mole, I'm dealing with 3 moles of water molecule. Meaning I have to multiply this equation with 3. So this portion, 3H2O, I can replace it with 3 hydrogen plus 3 by 2 O2. This will be at the top. So this is at the top. Bottom, I'll be having 3H2 plus 3 by 2 O2. So now something that I have not utilized, I'll copy it exactly like that. I'll keep it exactly like that. And this here it is 3 times the data given to me. It is minus 286. So now I've utilized this equation. I've utilized this equation. I've also utilized this because this was my equation which I had written at the top. See, minus 1368, minus 1368. So 3 equations I have utilized. I am left only with this equation. So using that, I will be linking it. I'll be linking it like this. So let me link it here. So this will be X actually. So now let's see if I'm able to get that. So when I'm merging this, I'll be getting, if I'm rewriting this, I'll be getting 2 carbon. Yes, it is there. Let's keep oxygen on hold. Now hydrogen, 3 hydrogen. Yes, there are 3 hydrogen. So I'm just writing 3 hydrogen. Next, we have oxygen. Here there is half oxygen. Here there is 3 oxygen. So now, from here, I'll be getting, this is 2 oxygen, this is 3 by 2 oxygen. So 2 oxygen plus 3 by 2 oxygen. So I'll be getting 4 by 2 plus 3 by 2, which is nothing but 7 by 2 oxygen. 7 by 2 oxygen. In order to check for oxygen, let's see. So I'm writing this side. 2 carbon, which is there as a reactant. 2 carbon plus 3 hydrogen plus 7 by 2 oxygen is giving me this as the product, ethanol, and 3 oxygen. So here it is 7 by 2, here it is 3. So when I'm taking this to the other side, I'll be getting 2 carbon plus 3 hydrogen plus 3 oxygen. I can rewrite it as 6 by 2 oxygen. And I'm taking 6 by 2 to the other side. So 7 by 2 minus 6 by 2 oxygen. See? Now C2H5OH as above. 2 carbon plus 3 hydrogen plus 7 minus 6 is 1 by 2. Oxygen gives me C2H5OH. See, this is also correct. 2 carbon plus 3 hydrogen plus half oxygen gives me C2H5OH. That is correct. So I have been able to verify oxygen also. And that will be X. Hope this much is clear. I'll give you a summary again. At the top, I'll be having the equation which has maximum number of compounds in it. So that was there with the bottommost equation. So I wrote that first. This was having maximum number of compounds. So I wrote that at the top. Then in that equation, I am having products with more compounds than on the reactant. In the reactant, I am having only 1 compound. In the product, I'm having 2 compounds. So my focus was first on the product side. For carbon dioxide, I had to multiply the given equation by 2 because in my target equation, I'm having 2 moles, but in my given equation, I'm having only 1. So I multiplied throughout by 2. So that was reflected in the numerical value also. So that's what you see here. Thereafter, I have to focus on water molecule. Coming to water molecule, here it is 3 water molecules, which is there in my target. My given equation has only 1. So that also I multiplied with a number. It is multiplied by 3. Now I've utilized this, and this. I'm left only with this. So I used to link it. I use that to link with the missing portion. I had just now proved how it is going to be equal to this. So yes, our cycle is correct now. We can just follow the pattern given in the cycle now. So now let's try to solve the numerical. Now let's try to solve this and get the numerical value. So this will be on one side. This will be on the other side of the equal to. So yeah, X minus 1368 will be on one side. That will be equal to, the other side will be having 2 times minus 393 plus 3 times minus 286. The arrowheads are opposing each other. So wherever the arrowheads are opposing, for whichever arrows I get it in a flow, I'll put it on one side. Wherever there is an opposing effect, I'll put it on the other side. So this will be X minus 1368 is equal to 393 times 2. So that will be minus 786 minus 3 times 286 would be 858. So I'm taking to the other side. X will be equal to 1368 minus 786 minus 858. I'll be getting it as 1368 minus 786 minus 858, I'll be getting minus 276 kilojoules per mole. This is what I'm expected to get. Minus 276. Minus 276. So that's it. Bye.